All right, another good rule that we can use for combining things together is known as the power rule. The way the power rule works is we have something raised to an exponent, and then we go ahead and we raise all of that to another exponent. So it's like we have exponents of exponents. And the way the power rule will really handle these is we'll take both of the exponents and we'll actually multiply them together. Now, to really convince you that this is the way it should work, we're going to deal with another example that has just numbers in it and show you that this is really the way you should combine your exponents in this case. So we're going to take a look at 4 to the third power, and all of that is being squared. So say you knew nothing about the power rule, how could you end up interpreting this? Well, one way is you could use, again, repeated multiplication to really interpret your exponents. So the first exponent I'm going to interpret is this 2 right here. So I'm going to take my base, the 4 cubed, and it will be multiplied by itself twice. So you can see I have 2 of them. Let's see, I want to go further with this. So now I will interpret both of these 3's as 4 being multiplied by itself 3 times. Okay, now that I've expanded it out entirely, I'm going to work to go ahead and package it all up. Because what I can see here is that I have a whole bunch of 2's, and they are all being multiplied together. In fact, I have a total of 6. So this is 4 to the 6th power. Now, go ahead and observe exactly what happened with the exponents. So originally we started with 3 and 2. And if you multiply those together like the power rule says we should, sure enough, you get 6. And if you follow along the process, you can really see why that happens. All right, so now that we know more about this rule, let's move on. The power rule, which we learned earlier, can really apply to multiplication and division. And the way it does it is we can take 2 things that are being raised to a power and end up giving each of them that exponent. When dealing with division, if we have things being divided, say a divided by b, we can take that exponent and again give it to each of them. So what I'm really trying to say here is that if you have an exponential expression and it's raised to a power, you can apply it to all of the parts on the inside as long as those parts are being multiplied or divided. This will really help us when we get to some of those larger expressions. All right, let's try a few of these out. So we simply want to use the power rule for each expression. Write it out. So the first one is 6 squared, and all of that is being raised to the 5th power. Well, I'm not going to expand this out. I'm just going to go directly to the rule. So this would be 6. Then we'd have 2 times 5. Taking care of just the exponents, this would be 6 to the power of 10. And, that's good. I could continue trying to figure out what number that is, but I'm only interested in demonstrating what the power rule is. All right, let's try another one. This is z to the 4th power, and all of that is being raised to the 5th. So I'll again take my exponents, and I will multiply them together. This will be z to the 20th. Not bad. All right, now let's get into a few that are a little bit more complicated and see how we can tackle these. This next one I have 3 multiplied by a squared multiplied by b to the 4th. So one of the first things I need to use is my power rule and give that 5 to all of the parts. Let's write out each of these. So I'm going to give the 5 to the 3. I'm going to give it to the a squared, and I'm going to give it to the b to the 4th. It must go on all of those parts, and it is okay since all of these parts were multiplied in the original. Well, now that I have this, I'll go ahead and start to simplify each of these. So my 3 to the 5th power is 243. Then I'll multiply these exponents together and get a to the 10th we'll multiply the 4 and the 5 together, and that'll give us b to the 20th. So now this one is completely condensed down as far as I can go. All right, let's see one that involves division. So I'm going to give the 3 to the top and bottom. So the top will be 3 to the 3rd power, and the bottom will be x to the 3rd. This will give us a 27 all over x to the 3rd. Okay, not bad. All right, let's try one more. 4 plus x squared. Let's see, what does the power rule say we should do with this one? Be careful. I threw this one in there because you should not use the power rule on this one. Now, why not? Why can't we use the power rule here? Well, notice the parts on the inside. They are being added, 4 plus x, instead of being multiplied. Well, since they're being added instead of multiplied, I can't simply give the 2 to all the parts. This situation down here is completely different from this one because of that addition. So how could I take care of this? Well, as we'll see in one of our future lessons, is that we'll handle this one using repeated multiplication, and then we'll simply have to multiply those two terms together. But for now, what I want to point out is you should not use the power rule on that situation. It simply doesn't work.